Welcome to this explainer. Today we're diving into the literal foundation of our modern lives. It's crazy to think about, but the entire global digital economy rests on the shoulders of just one company. And get this, most people have never even heard of it. So, we're going to explore how this single hidden engine quietly powers the world we live in. Because honestly, understanding this business is absolutely crucial if you want to grasp the future of technology.
I want you to imagine a scenario for a second. Imagine this hidden giant just suddenly disappears tomorrow, literally vanishes into thin air. Now at first, you probably wouldn't even panic. Your phone would still work perfectly fine, you'd still text your friends, check your emails, scroll social media. The immediate aftermath would feel completely, totally normal.
In fact, our daily routines would just carry on. Cars would still drive, your laptop would still turn on, and those massive data centers powering the internet, they'd just keep humming along. For a few weeks, life might seem totally uninterrupted. The hardware we currently rely on would hold the line for a bit, but that sense of normalcy, it would be incredibly fragile.
Because then, slowly, everything would begin to break. Without this one company, the forward momentum of the entire tech industry would grind to a devastating halt. New smartphones would become increasingly difficult, if not impossible, to manufacture. That rapid development of AI we keep hearing about, it would slow dramatically. Automakers would struggle to secure advanced chips, cloud computing companies would have to delay all their expansions, and the next generation of processors might simply never arrive.
So who is it? The company standing between our modern digital world and complete technological stagnation is a Dutch business with fewer than 50,000 employees? 50,000! I mean, to put that into perspective, in the grand scheme of global megacorporations, that is not a massive number at all. The company is called ASML, and without them, the digital world as we know it simply couldn't exist. They are the ultimate linchpin.
Okay, let's dive into this. Section 1. The microscopic canvas and how computer chips are made.
To really understand ASML's massive global influence, we've got to look back at their humble beginnings. Their story doesn't start in some flashy Silicon Valley garage. Actually, it started back in 1984 in the Netherlands as a pretty unglamorous joint venture between Philips and ASM International. No sleek consumer products, no revolutionary apps. Just a small engineering team facing decades, and I mean decades, of incredibly patient investment and uncertain R&D. It took years of solving one seemingly impossible problem after another for them to reach where they are today, holding a near monopoly that powers the modern AI era.
So what do they actually do? Their primary focus is a process called photolithography. Inside the devices you use every day are billions of microscopic transistors acting like tiny electrical switches. To make them, manufacturers can't just carve patterns into silicon. Instead, they use light. It acts exactly like projecting an incredibly detailed image onto a silicon wafer to form a microscopic blueprint. But here's the catch. Every single layer must align almost perfectly. We're talking about billionths of a meter here. Even the absolute slightest error can ruin an entire wafer worth thousands of dollars.
For a long time, the industry was cruising along just fine. But eventually, as chips needed to get smaller and even more precise, traditional lithography methods hit a brick wall. They were approaching hard physical limits. The entire semiconductor industry found itself staring down a terrifying existential threat. What if chip progress simply stopped? What if computers couldn't get any faster or any smaller?
Now, what's really interesting is how they solve that. Section 2. Engineering the impossible, the EUV machine. Facing those physical limits, ASML didn't pivot. Instead, they gambled billions of dollars to engineer something that many experts genuinely believed might be impossible: Extreme Ultraviolet Lithography, or EUV. This was the absolute holy grail of semiconductor manufacturing. To print the world's most advanced microprocessors, ASML had to build an incredibly complex machine that could generate ultra-short wavelengths of extreme ultraviolet light. They essentially had to invent entirely new physics to make this a reality.
You see, you can't just use normal lenses with EUV light. Glass actually absorbs extreme ultraviolet light, which would completely destroy the process. So traditional lenses and mirrors, totally useless. ASML partnered with Germany's Zeiss to engineer precision mirrors that are polished so perfectly that any imperfections have to be measured in fractions of a nanometer. Seriously, even the tiniest flaw would ruin the entire optical system.
And the way they actually generate that EUV light? It's absolutely mind-blowing. It literally reads like science fiction. Step 1, they drop microscopic droplets of molten tin. Step 2, they fire powerful lasers at that tin tens of thousands of times every single second. Step 3, each laser pulse creates an extremely hot plasma. And finally, step 4, it's that plasma that finally emits the extreme ultraviolet light. And this violent, incredible process is happening continuously inside every single EUV machine.
Let's move on and see how this all builds together. Section 3, the orchestrator, an ecosystem of innovation.
Creating that light is only part of the story, though. Building the machine itself requires an unprecedented level of coordination and a truly staggering price tag. One single advanced EUV machine can cost well over $200 million. And yet, the world's leading chip manufacturers, giants like TSMC, Samsung, and Intel, are absolutely desperate to buy them. Why? Because there's no real alternative. If you want to make cutting-edge processors for AI or high-performance computing, you just have to buy this machine.
And delivering these machines, it's a monumental task. Contrast the microscopic fractions of a nanometer precision we just talked about with this number, 180. That is how many metric tons a single EUV machine weighs. Transporting just one requires specialized aircraft, dozens of shipping containers, and a massive logistical effort just to get it out the door.
And once it arrives, it doesn't just plug into a wall. Each system contains well over 100,000 individual components. It requires teams of specialized engineers spending weeks just to assemble it inside the semiconductor factories. It is a modern marvel of manufacturing scale.
But here's the thing. ASML didn't do this alone. They understood early on that innovation rarely happens in a vacuum. Their machines depend on a vast ecosystem of global suppliers. We're talking ultra-precise optics from Zeiss, specialized lasers, advanced robotics, vacuum technology, and precision manufacturing software. ASML acts as the orchestrator. Rather than trying to stubbornly control everything internally, they rely on shared global expertise to piece together this giant puzzle.
So the crucial point we arrive at here is this. Section 4, the ultimate choke point, geopolitics and global reliance. This strategy has transformed ASML from a simple technology manufacturer into a highly sensitive, absolutely critical piece of global infrastructure. We're moving beyond just business now and right into the realm of geopolitics. Governments around the world now acutely recognize that advanced chips are the foundation of modern power. Just look at what these chips enable: artificial intelligence, advanced military technology, cybersecurity, scientific research, space exploration, and overall economic competitiveness. Literally every pillar of modern national security and progress depends entirely on the chips produced by ASML's machines. Because of this, ASML finds itself right in the middle of global affairs. As geopolitical tensions have increased, ASML's export decisions have actually become matters of international diplomacy. Governments consider this technology to be so strategically sensitive that some of ASML's most advanced machines are subject to strict export restrictions. It is incredibly rare for a private company to occupy such an influential position in international relations, but here we are.
And this brilliantly illustrates the great paradox of ASML. We live in a world where billions of people use technology every single day, yet almost none of them know this company even exists. Consumers celebrate the newest smartphone or the latest AI breakthrough, but true power doesn't always lie with the biggest consumer brands. Sometimes it lies with the quiet builders hidden in plain sight. ASML really is the company that enables the future before anyone else can build it.
Which leaves us with this final provocative thought. In a modern digital world that's so deeply obsessed with software, apps, and the cloud, what happens when a single, mostly invisible company controls the only physical machine that makes it all possible? ASML never tried to become a famous brand, but they became something far more valuable, totally indispensable. Thank you for joining me for this explainer. I really hope this changes the way you look at the devices in your hands right now.